Lesson 55 is dealing with adding and subtracting rational expressions. A little mini piece here. In 54 we discussed adding and subtracting rational expressions with like denominators. Well, with unlike denominators with a fraction, such as, let's say you had 1/6 and 2/3, in order to add them together, you have to find the common denominator. So we're going to talk about finding least common denominators of various polynomials. I'm going to show you a couple ways that you can go ahead and find least common multiples of polynomials. There is a couple steps here that you can take for finding least common multiples of polynomials. The first one is to find the prime factors of the expression, and then use each prime factor and the greatest number of times it appears, or also known would be the biggest exponent, in either of the factorizations, and then basically multiply that together. So if I use this method here, I'll say that this is step number 1, and that is to go ahead and find the prime factorization of each of the terms that we have there. So we have 6x. Well, if we break 6x down, the prime numbers of 6x would be 2 times 3 times x. And then we have 4x to the third power. If I prime factorize that, I'd have 2 times 2 times x times x times x. In step 2 says that we need to use the number the greatest amount of times. So in step 2, if you look at it, here's what it would basically look like in step 2. The greatest number of times that each of those prime factors would appear. Well, 2 appears once up here, but twice down here. So that's the greatest factor there for 2. So I'd add 2 times 2. 3 appears once up here, so that would be the greatest factor. And x, well, it applies once up here, but 3 times down below. So I'd have x times x times x. Now I'd go ahead and multiply this out. 2 times 2 is 4, times 3 more is 12, x to the third power. This would be my least common multiple there for a polynomial. Example 6, along the same lines. Here's another technique that you can use. Instead of using the two-step approach, you can go ahead and set up what I call as upside down division, or the L method. So basically you take your two terms like that and put it into an upside down division problem, and basically factor out what you can factor out of each of those terms there. So in this first set here, and it really doesn't necessarily have to be a prime number, but I can factor out a 4 out of this. 4 would go into 8, and 4 would go into 12. So if I factor out a 4, 4 goes into 8 2 times, and I'd still have m squared t. 4 goes into 12 3 times, and I have m squared t cubed. So again, look at this next branch here, or this next piece of the cake here. 2m squared t and 3m squared t cubed. Well, I can factor out an m squared out of both of those terms. So when I factor an m squared out, I'm left with 2t, and I factor out an m squared out of 3m squared t cubed, I would have 3t cubed. Looking at these terms, the next thing that I would be able to factor out, well, I can factor out a t out of both of them. So I'm left with 2, and I factor out a t out of the next one, I have 3t squared. To find your least common multiple then, basically what you do is you multiply all the things together. So 4 times m squared times t times 2 times 3t squared. Numerically, I kind of multiply that out first. So I take my 4 times 2 is 8 times 3 more is 24. And then I look for my m's. I have an m squared, and I don't have any other m's, so that would be m squared. And then I look at my t's. Well, here's a t squared times t, and then I would wind up with t to the third. So there would be my least common multiple. Two just two approaches that you can take, the L method there, or you can take the two-step approach listed above. When I work with binomials or trinomials, normally what happens here is I go ahead and use the two-step approach, not the L method. If you look at that previous problem there for the L method, we had a couple monomials that we dealt with there. So when I come to a binomial, I go ahead and use the two-step approach. So step one, factor that down into prime factorization here. So if I look at this first term here, I have 5m plus 15. Basically, when I prime factorize this, I can pull out a 5 out of this. So when I pull out 5, I'm left with m plus 3. And then I go ahead and check out 2m plus 6. So 2m plus 6. Here I can factor out a 2, and I'm left with m plus 3. So step 2 is to take the highest exponent of each of those terms, or the greatest number of times that they appear. And here's what I have. I have 5 appears once, so I'm going to steal 5. I'm going to steal 2. And then you can see that both of those terms have an m plus 3, that binomial there. So I'm going to multiply by that binomial. And when I multiply things out, I basically have 10, parenthesis, m plus 3. This would be my least common multiple. On to question or example 8. Same process. I don't have a monomial here. Here's a trinomial and a binomial. So I'll use a two-step approach. Basically, I'll take this first term, and I'll take this trinomial and I'll factor that first. So I'll prime factorization this, and I'll basically come up with a set of binomials here. When I factor it, I have x's here. I see plus plus is plus plus 18, so I would come up with 6 and 3, because it would have to have that sum of b, which would be 9, and 6 and 3 would give me that. So then my next term there, I have x plus 3. Well, basically that factors down to x plus 3. So step 2 is go ahead and multiply things together by the greatest exponent, or how many times they occur. And we have x plus 6 would occur once, and if you look in both of these terms here, x plus 3 occurs once in each of those, so I'd have x plus 3, and this here would be my least common multiple. This will conclude lesson 55, finding least common multiples for addition and subtraction of rational expressions.